Look, I learned to write first. Okay, so I want to convert the following. This is question number 30. So I want to convert the following polar equation into rectangular. So I've got 12 over 4 minus 8 cosine theta. So notice first of all, let me fix this. All right, notice first of all that my cosine is in the denominator and I don't want it there, so I'm going to multiply both sides by 4 minus 8 cosine theta, so 4 minus 8 cosine theta, which gives me, on the right side, I'm going to have r times 4 minus 8r cosine theta equals 12. And since I'm converting back into rectangular, I'm going to go ahead and get this thing on the other side, because I like the fact that I got an r cosine theta. Him, I want to be squared. But an r cosine theta is going to simply be x. So I'm also going to divide everything by 4. So divide by 4. So what I have is r equals 2. R cosine theta equals 3. So I'm going to add this term to the other side. So 2r cosine theta plus 3. And then from there, what I'm going to do is I am going to square both sides. So I've got this side squared and this side squared. So r squared, that's a gateway into rectangular, because that's x squared plus y squared. And that's going to be equal to this thing squared, which is going to be 4 r squared cosine squared theta. And then this, which is going to be 12 r cosine theta, and then this squared is going to be 9. Okay, so I've got this mess right here. Well, if I notice, this can be rewritten as 4 times r cosine theta squared, which means this is just x squared, and this is just x. So this gives me x squared plus y squared equals 4x squared plus 12x plus 9. So I'm going to pull my x squareds over. And I am going to get, hang on. Okay, I'm going to pull everything over to the right. So I've got y squared positive. So at this point, I've got a y squared. X squareds minus 4x squareds is a negative 3x squareds. Okay, this is going to be a negative 12x. And this is going to be a negative 9. And that's all equal to 0. So I was going to, all right, let's flip. I've got y squared, and I'm going to pull out a negative 3. So y squared minus 3 is going to give me a positive x squared plus 4x plus 3. Okay, x squared plus 4x plus 3 equals 0. And now I'm going to complete the square on this. Okay, so to complete the square, this is messy, Land of Goshen. You know what? Let's not do that quite yet. Actually, let's do that. Let's pull the 3 out of this one. So that gives me x squared plus 4x. But I'm going to take that negative 3 back to this and say minus 9 equals 0. So now I can complete the square on this. It'll just make it prettier. So half of 4 is 2, squared is 4. So now be careful. What did you really add? I didn't add just a positive 4 because I got a coefficient. I really added a negative 12. So if I added a negative 12 here, I need to add a negative 12 here. So let's write that down. So that gives me a positive 9 minus 12. So y squared. So I added the 9 over, and I've got a negative 12 on both sides. So I've got y squared minus 3 times x plus 2 squared equals negative 3. And I don't want a negative radius, and so I'm going to multiply everything through by negative 1. So that gives me a positive 3 times x plus 2 squared minus y squared equals a positive 3. Okay, I had to check. I want this thing equal to 1, so I'm now going to divide everything by 3. So this is standard form for an ellipse. So I have that over 1 minus y squared over 3 equals 1. Did not need the line right there. So divide everything by 3 because you want it equal to 1. All right, so we want to convert the following into polar form. So I've got a 2x plus a 3y equals 6. Well, I know from polar equations that I can swap out an x with an r cosine theta. I can swap out a y with an r sine theta. And that's going to equal 6. So I'm going to factor out an r here because I want to solve for r. So I get 2 cosine theta plus 3 sine theta is 6. And now I'm going to divide both sides by this set of parentheses. So I end up with 6 over 2 cosine theta plus 3 sine theta. Okay, so let's do another one. We have x squared minus 4y squared equals 4. Okay, and I want to change that into polar. So I cannot just swap this out as an r squared because this is x squared, this is minus, and this has a coefficient. So I'm going to go ahead and write this as an r cosine theta squared minus r sine theta squared equals 4. And now I'm going to want to solve for r. So I'm going to go ahead and distribute. So I've got an r squared cosine squared minus 4r squared sine squared is 4. And now both terms have an r squared. So pull out that r squared. So cosine squared theta minus 4 sine squared theta equals 4. And then we're back to just divide both sides. So I have r squared is 4 over cosine squared theta plus 4 sine squared theta. Okay, and because, I mean, if you want to, you can take the square root of both sides, but we don't want to do that, so we're going to leave it in terms of r squared. Hang on, I'm seeing where we're going. Okay, so I have, yes I do, give me a second. All right, sorry, I keep pausing to see how far I have to go with these solutions. So we're going to use a Pythagorean identity on cosine squared so that we're just in terms of one trig function instead of cosine and sine. We're going to be in terms of just sine. So this is going to become 4 over, cosine is the same thing as 1 minus sine squared theta minus 4 sine squared theta, which means when I distribute, I end up with 4 over 1 minus 5 sine squareds on theta. All right, so that's how we do that one. For the next 3, we're going to do the graphs of polar equations, and we're also going to check for symmetry. So if I want to know if something is symmetric about the pole, what I want to do is replace theta with a negative theta, and I want to see if everything simplifies down to the exact same thing. If I want to know if it's symmetric to theta equals pi over 2, I'm going to replace theta with pi minus theta and see what I get. Okay, so what does that mean? What that means is if it's symmetric about the pole in a Cartesian system, this would be an odd function. Okay, we're not in Cartesian, so it would be an odd graph or an odd function. So I would do 2 folds. I would fold it from positive x's over to negative x's, and then from positive y's down to negative y's. And if they lay on top of themselves, then they are odd. So remember, like x to the 3rd, I would fold it, I would get this, and then I would fold it down, and it would lay on top of itself. So this is kind of what we're testing, but we're in polar world. If I want to know if it's symmetric to the line of theta equals pi over 2, remember theta equals pi over 2 is the line created by all the points that are pi over 2 away from the positive x-axis. So I end up with, in Cartesian, it's your y-axis. So symmetry across y in Cartesian would be an even function. Okay, and we're just doing it in polar world. So to check for symmetry about the line theta equals pi over 2, we're going to swap out theta for a pi minus theta. and I should have made this arrows because they will simplify to the same thing. So what I want to check first is I've got r equals 3 minus 2 sine theta. So I'm going to check for symmetry about the pole. So I'm going to swap out a theta with a negative theta. So 3 minus 2 sine of negative theta. Well, sine is an odd function, which means if I change the sign in here, I also change the sign on the function. So it gives me 3 plus 2 sine positive theta, which means I changed. So it's not the same thing. So what happens if we want to test for symmetry about the line theta equals pi over 2? Start with the same thing. So 3 minus 2 sine theta, but we're going to swap it out for a pi minus theta. So 3 minus 2, piece of trash. All right, r equals 3 minus 2 times the sine of pi minus theta. So I notice I've got a sum and difference identity. So this is going to be my alpha, and this is going to be my beta, which I'll leave as theta. Okay, so if I want to use the sine of alpha minus theta, I end up with sine alpha cosine beta minus the cosine of alpha times the sine of beta. Okay, so what's my alpha? My alpha is pi. So I've got the sine of pi times the cosine of theta minus the cosine of pi times the sine of theta. Well, sine of pi is 0, so that whole thing zeroes out. This one becomes 0 minus the cosine of pi is negative 1. So I have sine theta, which becomes a positive sine theta. So when I swap out sine theta for sine pi minus theta, I end up with 3 minus 2 times the sine of theta. So I get the exact same thing back, which means this does have symmetry about the line theta equals pi over 2. So now remember to put your calculator in polar mode, good heavens, in polar mode, and make sure you're in radians. Okay, so hit y equals, clear all this stuff out, and I've got 3 minus 2 sine theta. And when I graph that, I will end up with a cardioid that is symmetric about the line theta equals pi over 2. So let's try another one. We have, hang on, I've lost my notes. What is new? I turned my fan on because I was hot, and now it's blowing everything everywhere. All right, so the next one is, this video is going to go a little bit longer. I've got 4 cosine theta over 2. So the first thing I want to check for is symmetry. So symmetric about the pole means I'm going to swap out theta for a negative theta. Okay, well, cosine is an even function, which means it doesn't matter if my theta is positive or negative. It will return the same y value, which means using a property of an even function, I get this back. So it is symmetric about the pole. All right, so to prove this one, I was going to make you do it yourself, and I changed my mind. Remember that I can write this as a pi over 2 minus a theta over 2. So it's just a common denominator. So this is going to be my alpha and my beta, which means I am testing to see if 4 times the cosine, so this is cosine alpha minus beta. So I've got cosine of pi over 2, cosine of pi over 2 times the cosine of theta over 2 plus the sine of pi over 2 sine of theta over 2. Cosine of pi over 2 is 0. So I've got 0 plus the sine of pi over 2 is 1. So I've got the sine of theta over 2. So I get 4 sine theta over 2. So it is not symmetric. Okay, so when I substitute in, I do not get this back. So it's not symmetric about the axis, or I'm sorry, about not the y-axis, but the line theta equals pi over 2. So when I graph it, I have 4 cosine of theta over 2. So theta over 2. And when I graph him, I get, ooh, that's pretty. I get a bunch of stuff, okay? So that's what I get when I graph that. All right, so what do I have now? I now have, I've lost my notes, and I just dropped everything on the floor. Can you tell I'm hurrying? For the love, stop blowing away. Okay, give me 2 seconds. I got to find the next problem. And the next problem says, okay, so I have r equals 4 cosine 4 theta. Okay, so I am going to check for symmetry first. So check for symmetry about the origin. So for negative theta, or about the pole, good heavens, I'm trying to hurry and I'm stumbling over my words. So I get negative 4 theta. We're checking for symmetry, not about the origin, but about the pole, which honestly some people say it's the same thing. This is an even function, which means if this is negative, it won't affect the output. And so I get the exact same thing back. So he is symmetric about the pole. For the next thing, we're going to substitute theta with a pi minus theta. So I have 4, oops, I do not. I have 4 cosine. Instead of theta, we're going to do pi minus theta. Okay, so 4 times the cosine of 4 pi minus 4 theta. So again, we're going to use addition, subtraction of sum or difference identities. Okay, so cosine of alpha minus beta will become the cosine of alpha times the cosine of beta. That's very squishy. All right, minus, the sine of alpha times the sine of beta. Okay, so cosine of 4 pi is 1. So 1 times cosine 4 theta. And then the sine of 4 pi is 0, so this goes away. So I end up with the exact same thing back. So this has symmetry both directions. So it is symmetric about the pole, and it is symmetric about the line theta equals pi over 2. And so we're going to kill that off for cosine 4 theta, and we're going to graph him. Ooh, look at that pretty picture. All right, so you've got a rose. You have a rose with 8 petals. And we'll pick it up in the next video.